take a peek at your assessments. Make sure you guys didn't lose any points. Thank you, Tony. Make sure you guys didn't lose any points you weren't supposed to lose. If anything's bothering you, come see me at the break. We'll figure it out. Okay? I got an email from Amber this morning. She said she was ridiculously sick over the weekend. So I'm thinking that when I get back to my office, she said she was going to grab your papers from last week at 9 a.m., have them graded and back to my office. I've got a negotiations meeting from noon to 3. I apologize, I have to cancel office hours today, which sucks. I hate doing that. I'm going to have more on Wednesday to make up for it, but I hate having them, yeah, anyway, I apologize. But my point of telling you that is when I get back from that and head home and get my little guy from school, I'm going to head home right after that and input all your grades and send a progress report out. So everything I got back from Emily, I'm going to disinfect to make sure that she doesn't get you sick. And then we'll put it in the progress report and get it back to you, and then we'll get you the papers back on Wednesday. So you'll have a progress report before your papers. Tony, go ahead.
Are you going to take questions on the exam?
Sure. What's the question? I'll answer as generally as I can.
General,
give me a general question. Tom, you had one from before. Go ahead.
Well, actually, mine was on the quadratic regression quiz.
Oh, but what was the particular question on the quadratic regression quiz?
Well, I just got stumped as soon as you asked me. Projected out in 2011.
We have the same.
Sure you do. Because you have a mock. Question is, this is a fantastic question. If you're doing the quadratic regression quiz, I have a timeout to ask. Is this one due today or did I push this one back?
It's Wednesday.
This one's due on Wednesday. Now, I did make a couple of adjustments for due dates on a couple things because of where we're sitting. A couple data sets took us a little bit longer to analyze, so I decided to push back. So I pushed back quadratic regression, yes. I know I pushed back the golden ratio one too. So those are both, if you want to turn those in on Wednesday, that's totally fine. The original quiz due dates I made today because I knew you had an exam on Wednesday and I hated to have all this stuff due on one day. But at the same time, if it buys you 48 more hours to work on something, let's just push it back. So to answer your specific question, Tom, and this is a general question if I may, can I have your... So what I've given you here is I've given you data from 1980 through 1997. And you run the regression, you come up with average rates of change and blah, blah, blah. It's fun, fun, fun. Then I asked you to predict 2011. Well, that's why you make a model. You then substitute the 2011 into your model and see what comes out. We did the exact same thing with Mount Bachelor. We did the exact same thing with health insurance, number of uninsured Americans over age 65, under age 65. We did the same thing with Facebook, exactly Facebook. When will it so basically the idea is you just take whatever the input is and use the model to predict. And then later on, you can do it a bunch of different ways. You can use your technology to do it, or you can run it. You can actually take the equation and run it through. It's your choice. But don't think it's a different skill from the linear model. It's exactly the same thing, but now it's quadratic. I mentioned to you guys when can I borrow your booklet real quick here, Courtney? Thank you. This booklet, this wonderful little booklet about how to run the data in. I made a mention that the only thing different between this and quadratic modeling is the button you push in step, hang on, 3B, where instead of selecting 4, you select 5, and that is literally the truth. Every bit of math you do is identical, so you don't have to relearn the math each time, it's just a different menu selection as far as what your model is. Golden?
I'll give it a shot.
Yeah, you can, absolutely.
Now the other one, and probably, I don't know how many people do the homework, but
yeah.
I got about a third of the way through the first page, and then throws a whole bunch of
average rates of change.
Throws in a whole bunch of.
Oh, you're messing with the algebra one.
Yeah.
So don't worry about those. You can skip those if you want. Tom's concern. This is a good one actually, Tom. There's a number of homework questions that are very algebra based. F of this minus F of this, F of this minus F of this. If those are giving you algebra, just skip over them. You don't need those for success on the quizzes or the exam. So you can see, those are kind of, the homework is being developed kind of as a, and thank you for that input, because this is going to help me. If you don't mind sending me an email about this, in the future what I can do is I can actually segment the homework out into basic, sort of advanced, and then AP, and you can decide whether or not you want to dive deeper and get into the AP stuff. Thank you. If you don't mind sending me a note about that, Tom, you can stop right there at these guys. If you can get down through here, you're solid. Everything else becomes very algebraic based. It's kind of a residual. It's been there for about 1.5 years now. And I would not be surprised if you're one of the first people to actually attempt them. So don't sweat them. Please don't sweat those. Tony, you had a general question?
No,
Ask.
not yet. I'm just saying that if I
Email me. If you look at it and you get stuck, email me.
Okay.
Yeah, I already had one email, and this is a technological question that might give you some agita. I'm going to show you something real quick that you have to open, obviously, for the exam. Let me log on. Crap, I gotta log on first. There are two Excel spreadsheets that you use for the exam. One involves grade change, depending on sliding the angle, and one involves Usain Bolt's data from the 2009, I think, set a world record in the 100-meter ridiculous dash. Both of them require you to use Excel in kind of a slick way. One of them has a slider bar, and actually they both have slider bars. And I've been getting some technological concerns from people that when they open the spreadsheet on their own computer, their menus aren't the same as mine that I'm explaining. Because there's accompanying videos for each one.
The video doesn't work.
The video doesn't.
Yeah. Not for the, no, I tried it at home, I
For
tried
which
it
one?
in the tutor.
Hang on,
I
time out.
got on both of them.
Hang on.
I got on both of them.
Hang on. Now, this is where technology is awesome and crappy all at the same time. Because when I build the assessments, here we go right here. When I build the assessments, let me fire up a window here. I build them on a school computer. Why do I do this? Why don't I build it on my home computer? Running OpenOffice, Unix operating system. Why don't I build it on that? Because you don't have that. Most likely. I try to build it on a school computer because you all have access to this. So, let me go S rule, let's do week 5. 5, here we are. Okay, here we go. So here's your exam. So this guy here is not working for you?
No, and I tried it at the school and
Mine
I tried it in
worked
school
on
before I left.
Okay.
Got it to
I
work.
don't have an answer for that. Well, I do have a potential solution because it just worked here. Highlight,
I did that.
right click, try opening in a new tab. What I just did right there, I right clicked on it and you can go open link in a new tab, it'll pop over here. Tried that.
Okay.
Okay, now Dean, you said it worked for you just fine. I'm assuming it did work. A couple people that have emailed me have mentioned that they've been working, so when you click on it, let me ask a question. When you click on it, does it up here, do you see a little circle going like this indefinitely?
I don't know.
I've noticed sometimes at school, I can't explain this, but at certain times of day, some things won't load quickly. I don't know why, but sometimes that's an issue.
Keep saying try again later.
That's exactly the error, and I don't know what's causing that. I haven't gotten a good answer as well, so I can't tell you for that one, other than try to get it. Or send me an email, I'll send you the links directly.
Okay.
You can, I mean, these are all on my YouTube channel, so I can send you the links directly to you, so you don't have to worry about it. I think also, if the old school we used to do it was we put our mouse over there, see what I'm doing right there? And then down there at the bottom, there's the link.
Oh.
So old school, this is what we did back in the 90s before you could do things like selective face. We just write that down and type it in, which is inexcusable in this day and age, of course. But that's one way to work around it. I don't know why why you can't launch the link. I wish I did, but I don't. Tony, go ahead.
See, what time of day is I usually not working?
I noticed mine are late in the afternoon when I'm uploading all the YouTube class videos.
Probably because all your teachers are probably doing a lot of.
Quite possible. Quite possible. There's a bit of an animal in the system. But the problem is that's when I have to do it. Like there's no way around it. That's when I get back to the office, I dump the camera, and I start uploading. So I'm making the problem worse by uploading 12 to 16 gigabytes of information. And I'm sure COCC loves the cable bill when I'm online. Fair enough. Let's check the other one too. Usain, here's Usain. Boom, she works too. Okay, so you're good. Now this one in particular is the one that a student was gave me a concern about, and I want to make sure that you guys. This is explaining. There's no volume for whatever reason right now. I don't know what. Oh, I can hear me. Just turned down. So, my sweet little voice talking to you while you're working. When you click on this, certain menus appear. His concern was that he's not getting the same menus. So here's a scatter plot, just random. This is not your data from your exam. It's different data. But you'll do it on your data from your exam. Same thing. But when you actually click on the spreadsheet, which I'll show you, a certain set of menus comes up, which you'll see here eventually once I click on it. If you're not using the same version of Excel that the school has, you might not get those. So when I sent the email back was, I said, are you using your own version of Excel? If so, send me a screenshot and I'll tell you how to get what you need. But honestly, it might be easier just to find 20 minutes and go to a school computer and knock it out there. Honestly, in all honesty, it probably is easier that way. Is that fair enough? So if anything like that happens, shoot me an email. I'll get right back to you as soon as I get the email. But don't let technology, see right there, chart tools. He was saying he doesn't get these 3 tabs.
I only get 2 of them.
That's what he said. Which, you do it at home?
So that, yeah, so
That's
then
what
I have
happened.
to just go over to where it
Take a
has the
screenshot
chart
of what
things.
all that, yeah, you can get everything you
I got
need.
into it fine.
Excellent.
I had to go over to the chart thing. On
And
the
this is
left-hand side.
this is the problem with technology. As wonderful as it is, it does have these little bit of hiccups. Because if you're not using this is why I gave you the caveat on the first technology, yes, quid pro quo, yes, everyone must use 2007 or higher. Because the idea is, the videos that I make to accompany them like this are tied to that version. If you're using 2003 or 97 or 2000, they might look a little bit different. So if anybody gets agita, I mean, just go to school, log onto a school computer, fire it up, and it'll look just like this. You know, I built this on a school computer, so.
So it should be fine if we're using 2007 or
2000,
higher.
what this is built in is 2007, yes ma'am.
Okay.
2007, absolutely. So, or you have to kind of reverse engineer the menus to figure out what you need. But if you're using 2007, this whole argument, this whole discussion doesn't apply to you. Because it's going to look just like this at the end of the day. We're actually going to do this in class today with some more data I can collect together. But so that was a good question. Thank you, Tony, for that. I appreciate that. I think that was your question. If that wasn't, somebody asked me that question. Thank you for it. Any other general questions about this? I'm glad. Let me fire up the spreadsheets while we're in here. Why not? Let's take a look at those. Escape. Back out. Okay, so the spreadsheets are actually back here. This is the triangle spreadsheet. Okay, it's going to tell you want to open it. Yes, go ahead and open it. And the idea of this one, and some of you have already messed around with this. It's fantastic if you have. It's going to allow you to shrink it down so you can see it. It's going to allow you to edit this triangle. Edit this triangle with this slider right here. So as you click through the slider, you're essentially doing what you guys did in class 2 weeks ago out on the stairs. Aren't you glad we didn't do it now when it's still when you were doing the tape measure, it's doing that for you. Every time you click, you're changing the stair steepness. Right now the stairs are pretty steep. Why are they pretty steep? Because the angle is at 52 degrees. That's over 100% grade. And you'll understand why as you go through the first couple questions, why it's over 100% grade and so forth and so on. So you're just clicking through. It's giving you the tangent and the sine. The sine, if you're forgetting what the sine was, it's mentioned in your homework. It's also mentioned somewhere in the exam, and it's also mentioned on a quiz from a couple weeks ago. If you need more, just shoot me an email. I'll happily send you more. Happily send you more about that. But basically, this is the right way and that's the wrong way. There was a right and a wrong way of doing it. I think we mentioned it in class that day too, where I called it the sine. The sine is the wrong way and the tangent is the right way. And we decided for a while that there was no difference between them for certain values of the angle. The point of this problem is to say, okay, at what point do they become really, really different from each other? Notice right now, they are ridiculously different from each other. This is well past the angle that you would use this on. And this question came to be because I was in Salt Lake City with my dad and my brother-in-law, and for a small price you can ride the bobsled that was in the Olympics back in 2002. They've got it rigged up. It's not on ice anymore, it's on wheels. And we were looking at it, and we heard people screaming as they were coming down, because I guess it pulls like 3 or 4 Gs in each one of the turns. And my dad was like, I wonder how steep that is. And I looked at it, I'm like, what's the run, a mile or something like half a mile? I did the mile divided into the drop, and I'm like, oh, time out, can't do that, that's this. And he's like, oh, it doesn't matter. I'm like, well, actually it does. You hear him screaming? That means it's pretty steep. That means the angle's steep enough to make a difference. He's like, yeah, clever. So it does matter sometimes when you're talking about grade. With roads, generally not. That's why with the roads we calculated, we didn't care. The one question on your exam about the elevation plot of my bike ride, doesn't matter if you do it the right or wrong way. Completely irrelevant, because the grade, I'm never pulling a 52-degree angle on my bike. If I was, we'd be professional cyclists if we could pull that off. Like around 52 degrees. It's like right on a brick wall. So the idea is this question you actually explain at what point does the angle get so great that you shouldn't do it the wrong way anymore. And that's what A through E kind of walk you through in that one. So that's that spreadsheet. Hopefully you're having luck opening that one. This one should open in any version of Excel. Dina, you said you have the older version?
Yeah.
Did this one open in your older version okay?
Yeah.
And the slider
both
works?
of them, yeah.
Okay, good. That's one thing I was concerned about, the slider. I wasn't sure if the slider reverse engineered into the older version. Sounds like it is. And the only other one is Usain Bolt. Let's crack him open too. Yep. And this was, so that particular Excel spreadsheet was tied to that first YouTube video. The second YouTube video is tied to this one. There's a beautiful little scatter plot. So there's Usain's position data. This is exactly like my bike data, except he's an Olympic athlete running, and I'm me riding a bike down a hill. So what you're seeing is you're seeing time going by, and you're seeing distance he covered. It's out of 100 meters because it was the 100 meter dash race, whatever they call it. So that's what his data is. And here's the raw data over here. And so it's going to look just like it did in yesterday, last week in class with the average rate of change. And you'll see when you start clicking on this, as soon as you start clicking, you start getting these chart tools, and you're going to explore this trend line, which is what that video walks you through. That's what that video is all about, is how to drop a trend line. And we'll do it again today. Well, I got some data to collect today. We'll actually drop a trend line onto with Excel, so you'll be able to see it kind of in action as we go. And then as you go through it, as you actually start going through it, you'll start seeing how to calculate his average rates of change, the AROCs or the IROCs. Now, average rate of change was what we were talking about in class all the time last week. But at the end, when we shrunk down the points so they were very, very close to each other, we didn't call it the average rate of change, we called it the instantaneous rate of change. We called it that once or twice, not as much as we were using the word average rate of change. And technically speaking, it's still an average rate of change. But the idea is, when you shrink so that that point and that point sit on top of each other, it's actually not average anymore, it becomes instantaneous. Because at that moment, he's going that fast. Right now, he's going 12.2 meters per second on average, between 5 seconds and just about 10 seconds. That's his average rate of change between those two time periods. But you can tell by the curve, that's not actually what's going on. He was actually going faster on this side of it, and then slower over here. Just like on my bike. Remember on my bike, we tried to stretch a straight line between the curve? It was missing the curve. Just like that. Same thing happened with Usain. So your goal in this one is now to grab that second point and start messing with it. See how it's moving? And you see how his average rate of change is changing? Now, if you get impatient, you can grab it like this too. It's going down, it's going down. Why is it going down? Well, I'll give you one hint. You ever watch one of those races?
Slows down.
They slow down at the end. I don't know why. I'm assuming because you can't run at that speed for more than, say, 50 meters before your legs explode.
I think because the race is ending too.
The race is ending, but man, wouldn't you want to just bomb across the finish line?
Yeah, it's a little-
I mean, he set a world record even slowing down. A lot of times, too, I've noticed those guys look around at about 50 and 60 meters, and they're like, I'm going to beat him. And then
Everybody's there though.
I don't need to run any faster because I've already beaten everybody. Sometimes it's not the time, it's the place. As long as you finish first, second, or third, you're golden. So if it's a prelim race, why blow yourself out at a prelim?
Well, and plus they've got other races and they're running other events.
200s, Usain, I believe, has a record in the 200 as well as the 100. Exactly. But it's the kind of thing, if he was going for the world record, I mean, why not just bomb through the entire thing? This is how I'm thinking. Of course, I'd still be back here in the time he finished the damn thing. But that's just me, actually back here, I guess. So that's the idea of this spreadsheet. It's doing, I think what you guys might be nervous about is, you think you should be doing math. It's doing the math for you. You did the math all last week. All those TI calculations for that in-class quiz, it's doing it right here. See this right here? Remember the y1 minus y1 over difference? That's what these are. And that's the ratio. If you click in that cell, you'll actually see it.
So it's actually just doing
Look at that right up there. I don't know if you can see that command or not. D9 minus D10 over C9 minus C10. D9 minus D10 over C9 minus C10. Y2 minus Y1 over X2 minus X1. That's what you guys are doing in class. It's just doing it for you. And the reason I'm having you do it in Excel is twofold. Number one, I want you in Excel. Graduating students from a two-year school and not using Excel is punishable by public flogging with wet noodles, in my opinion. You guys should be in Excel experiencing this, getting frustrated by it. You should be getting frustrated by it because you need to be able to use Excel or some kind of a spreadsheet. And number two, there's no way I can really ask you, especially in this last sheet. Because did you guys catch as we get closer and closer to the end, the average rate of change or the instantaneous rate of change is slowing down? And we just said he slowed down at the end. So where was he going the fastest? Well, that's what this, as you explore. That one, you have two sliders because you get to pull both points. You get to move not just the one, but also the other one and kind of go back and forth.
I have a question.
Yes.
Why do they always make them look back?
Make them look.
Even like with your bicycle one?
Why time and distance?
No, they have it like this, but you're actually going like this. You know what I mean?
No, I see that. Don't confuse my position on Earth with what I'm graphing. I'm graphing how much distance I cover versus how much time it took me. So the longer I'm on that bike, the more distance I'm covering. Longer, more. Longer, more.
Well, they make it.
You're talking about elevation. You're talking about elevation, not distance covered. The elevation, to answer your question, Kel, look at the question on the exam about my Mackenzie Pass ride. Then you can actually see my ride. If you looked at that graphic yet for the exam on the Mackenzie Pass ride, I put that on there, right? Mackenzie Pass ride. Is that on the exam? Those of you who looked at it? I think I did. I lose track of what I put where. Hang on, let's pull it up. I guess I didn't.
Just kind of you.
Oh, I didn't.
It doesn't have it.
Maybe I'll give you a quiz with the Mackenzie Pass. So there's an elevation profile I have. I put a GPS unit in my back pocket and rode from Sisters up and over Mackenzie Pass to 126 and then back over. And you can actually see my elevation. So you're like, oh, that looks like it's supposed to look. But that's because the plot on the y-axis is elevation, not distance covered. It all depends on where you're putting your dependent variable. So that's why it looks backwards to you. We're not plotting my elevation. I don't care. I never once did we actually measure how high I was in the beginning on Monday and how far I dropped to the end. We never measured that at all. We measured how long it took me to get past certain markers. The elevation was irrelevant. To me, it wasn't. I tried to find something that was uniformly steep, and that hill, do you guys notice? That hill wasn't perfect. It ran out towards the last 50 feet. It was pretty consistent and then started running out. At one point, whoever, Tony, I think was you that had the tape, I kept making you walk backwards. Go backwards, go. I was trying to use as much of that consistent hill as I could, but I still didn't have 200 feet worth of it. So I was just trying to make it consistently downhill.
So, but they don't. So, but they wouldn't show it like coming from the top of this thing going that way. It's just the opposite.
Yeah, it's distance covered versus time used to cover that distance. Well, it depends on what you're interested in. When you talk about driving a car, well, think about this. When you talk about driving a car, you don't care about your elevation in general. You care about your miles per gallon. Miles per gallon. Or you care about how long it's going to take you to get to Boise.
I'm at the angle.
But you don't care about that most of the time.
We just wait, look.
I know how it
Here, going
looks.
this way.
I know how it looks, but how it looks, it's like graphing the stock market price versus volatility. I mean, one of those might go up logically going up. I like what you're saying, because what you're saying actually bothers a lot of people. A lot of people, when they take, for example, a Math 95 class and you talk about shooting projectiles off of cliffs and things like that. Oh, that's the path the rock takes. Actually, it's not. It's the height the rock is at a certain time. It looks like the path the rock takes, but it's actually not that. So it becomes a graph reading kind of exercise. Is what am I looking at? Oh, I'm looking at a crude distance over a certain period of time. And I like what you're saying, because I think a lot of students feel the exact same way with it. Why is it going up? It should be going down. You're going downhill.
Yeah.
Ask yourself what you're looking at.
Yeah.
So I'll give you an example of a perfect example of that. What would this be a graph of? Because it could be. Actually, I probably know I'm showing my age with this one.
So, yeah, they're trying to get.
Time, temperature. Okay. Goes on pretty much indefinitely. Here's a graph. What would that be a graph of? What do you think? Say that again.
The change in temperature over time in Central Oregon.
And over what period of time, Amber?
20 years.
20 years. Like it. Like it very much. It's a little extreme for that, though, and only because I track that. Generally, that data looks, I'll just draw this out. It looks like this, essentially, arguably this. And this is not drawn to scale at all. I like what you just said, and actually, if you ignore the tail in the beginning, the end part is exactly either on a daily basis or an annual basis. It's very, very clever. If you look at, let me show you actually. If you look at, there's this data set exists all over the globe. Let me show you real quick some neat data. I don't have a graph for Central Oregon, whoops, but I do have a graph of Mauna Loa CO2. Oh, there it is right there. So if you take a look at this, this is CO2 concentration on the horizontal axis over here, or vertical axis, excuse me. And this is years, 1960 up to 2000, looks like about 2010 on the graph. And do you see the little spot, the little up and down, up and down, up and down, up and down, up and down? Is it, up and down, 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 up and down. There's Al Gore's little cutoff. Up and down, up and down, up and down.
Is that post-global?
Is that
Why do we have an up and down? Come back to that, come back to that. Why do we have an up and down?
This is constantly changing
Why is it constantly changing? CO2 emissions. CO2 concentration, why?
because of the temperature.
Why? This is Mauna Loa, it's always like 80 degrees there.
Because you're inhaling, exhaling, I don't know.
Do you think your inhaling, exhaling is going to change? What is inhaling and exhaling more at certain times of year than others that would make a bigger effect than us breathing as humans?
Plants.
Blooming season, non-blooming season. Now, in Hawaii, it's always 80 degrees and perfect, as we've always heard when it's going to Hawaii. But the plants have a growing season and a resting season, just like any other place. So what you see is, you see the emissions drop off. These are annual. If you count the number of ups and downs, there's about 10 per decade. And so you go from 1980 to 1990 and go up, there's about 10 of those cycles in there. So when they're the highest, it's when the plants are respirating least. And when it's the lowest, it's when the plants are respirating the most. And remember, plants breathe in carbon dioxide and breathe out oxygen. So they're going to absorb more of that. So granted, yes, cow methane, I've heard cow methane causes global warming. Whether it does or not, it has more of an effect than we do as humans, because there's more cows farting more methane than us breathing carbon dioxide out. But the fact that the plant cover at Mauna Loa is exponentially greater than anything we're doing. So here's the idea. There is an interesting little cyclical, but it's also tilted upward, isn't it? Which means that over on average, and this graph received a lot of media attention until you look at the 320 and the 380 and realize that they cut off 0 up to 320. Does that make sense? So it looks very steep, doesn't it? It should look more like this. It is creeping upward. It is creeping upward. But the question is it creeping upward at a large enough rate to be worse? I don't have an answer for that. So I don't have an answer, Trey, for your global warming issue. I don't, unfortunately. All I know is there's at some somewhat arbitrary point, they changed it from green to red, obviously, to make it our attention. So, but back to Amber's question, though, there are occurrences of this kind of data in nature. Just this isn't particularly one of them. Anybody got a solution for the first one? I'll give you a hint. Chelsea, go.
Well, for the green line, I'm kind of guessing like an air conditioner. Cause
You're close. You're damn. Actually,
Or a
I
fan.
love that, except we're going the other way. I love that. Chelsea, go the other way. Jacob.
Could it be like an oven?
That's exactly what that's how I drew it. When you turn an oven, I was going to put a number here, 375. Because we made a pizza the other day, 375, 0. Okay, the oven's in room temperature when you turn it on. It goes up to that temperature, usually overshoots it because it's rising. It's got a temperature gauge, it drops itself off and then hovers around that. So you see what I'm saying? So the idea is data can do varying things depending on what part of the data set you're looking at. And that's what you're analyzing in Usain. Usain's data changes halfway through. He's hauling. Watching those guys accelerate is terrifying. Absolutely terrifying. But then something happens about halfway through, and it changes a little bit. And your job is to kind of analyze that with the mathematics. So, cool? Fair-ish? I apologize for all the technological goofs that happen. They're going to happen, unfortunately. It's just kind of the way it works. It does happen that way, which is a bummer. But at the same time, if you all use school computers, you won't have any issue whatsoever. I can't explain this one, not working at school. So try, as long as if you still can't get, I'll send the links directly to you. Just send me an email, okay, I'll do it for you.
That's been bad luck.
It
Bad
could
timing,
be.
I guess.
It could be. I can't explain why they wouldn't load for it. That's weird. YouTube has issues sometimes. I mean, last week when I was trying to put your videos from Wednesday into the playlist, it kicked me out and I had to go back in and then redo it along that. I mean, it's got issues. Technology is not perfect. But by and large, it's still a wonderful thing to use in spite of the hiccups. Cool? Email me if you get stuck with anything else. By all means, by all means. If I'm in my meeting this afternoon when you email, I'll happily leave it. Trust me, happily leave it. Meetings, great ways to kill productivity. I want to come back real quick. I want to collect some more data today too. We'll see if we get to. We'll see if we get to the coin flipping and the card drawing. But I wanted to kind of show you guys some other. Oh, you can't see that. I want to show you guys. We're not doing a whole lot of modeling in this class. We're taking our time with the modeling we're doing, which I'm glad we are. But we are taking our time through this modeling.